Okay, we got a couple messages that point in the right direction. Our interface came up and we are seeing protocol up on it. Let's go ahead and exit out of configuration mode. I'm just going to do a Control Z to break all the way out and wait till it gives me that message. Now, one of the first things we want to do is do a show IP interface brief. What I like to do is I like to exclude unassigned, so you can say UANA. I end up typing as ask because I've got the mind of a 12-year-old and it's easy to remember. This is just going to give me the interfaces that actually have an IP address assigned to them, so we're only going to see that. Whereas if you did a show IP interface brief, you'd see all of them. Not a big deal in this case, but a lot of routers now have tons and tons of interfaces that don't have layer 3 addresses assigned, and we're really just interested in the layer 3 address here. So let's go ahead and take a look at this guy, and you can see status is up, protocol is up. It's looking beautiful so far. Let's go ahead with some of our verifications. Show interface, I'm just going to use less letters. I don't need all the letters for this, so show interface as 0/0, and we can see it's up and up. We already knew that information. Encapsulation frame relay, it looks great. LMI, and you can see now we have numbers here. We have LMI sent and LMI received, and you want these numbers to be pretty much within one of each other. I'll go into that in more detail in the LMI lesson, but LMI is up, which is great. And then we can see here, well, nothing much has been sent. Let's go ahead and take a look at some of our frame relay verification commands. We do a show frame relay LMI. Going to give us some of the same information that was up here, but with a little more detail. If you need to check the invalid dummy call reference, which I have no idea what that is, it's good to look here, but I like to look at this full status, and you can see that we are good to go. What's interesting here, if you look at this LMI type, and we would have seen this up here as well, is ANSI. So what happened was the interface came up, Cisco AutoSense kicked in, it sent, like I said, one of each of those LMI types, which are Cisco, ANSI, and Q933A. And so what responded, obviously, was ANSI. So this frame relay switch is actually speaking ANSI. It's not speaking Cisco. So it went and dynamically changed that, which is a good thing. So we don't have an issue with our DTE to DCE communications. So that's a good one. And now show frame relay. And here's the big one. Let's do show, was it map? Or is it mapping? It's map. Okay. Well, before I do that, I'm sorry. Let's do show frame relay PVC. There's a couple of options with this. I'll show you right now just the full. If you hit enter, you get all the PVC information. And there's a ton of information in here. And actually, there's 2 PVCs here. That's interesting because I don't remember configuring this 102. Oh, you know what? 1 second. Yeah, I might have screwed something up. We'll see rather quickly. Anyways, you can see here Delcy 101. That's what we're really... No, we don't. We want Delcy 102. I did screw something up. Ha. Let me run int as 0/0. No, I didn't. Interesting. This one's active. This one's deleted. 1 second. Yeah, I really didn't want to get into troubleshooting here. I screwed up. If we jump back to GNS3 and we take a look at the configuration of the frame relay switch, you can see that I have Delcy 101 assigned here. It should have been 102. Can't really change this when this is in progress. So what we're going to do is amend our configuration. So that's why we're seeing this. Let me go ahead and cancel this. Bring this up real quick. Yeah, you get to learn from my mistakes. So what I did was I configured the frame relay map for the remote IP address to the local Delcy, which is 102. Except that I fucked up the configuration in GNS3, and the Delcy that's actually being assigned is 101. This is one of the downsides, and again, we'll get into this in far more detail when we go through mapping, is that when you manually map a Delcy, the router assumes that that Delcy exists. It's going to show up deleted here because what we're saying is I want to send stuff out Delcy 102, but the router's like, well, I haven't heard anything from the frame relay switch about this Delcy. What I have heard is I've heard of the existence of 101. This is good for troubleshooting. I really don't want to get into troubleshooting here. What I'm going to do is I'm going to go into configuration mode, 0/0, shut this guy down, and I'm going to issue a no frame relay map. Take out that map, paste this guy in, and all I have to do is change the Delcy here to 101, do a no shut. So now let's go ahead and show int 0/0. We're up and up. Our LMI is fine. We don't need to go check that. It's obviously not an issue now. If I do a show frame PVC, I only see Delcy 101. I see it as active. This is what you want to look for. You want to look for the status. Active is good. Everything else, pretty much deleted or inactive, is bad. So we saw earlier deleted, and that is not good. That means a problem exists between your device, your DTE device, and the frame relay switch, which is DCE. And the problem was that I boned up the DELC. So anywho, got a little bit of troubleshooting in there. And then the final command is to show frame relay map. And here we see that we are mapped to the remote IP address. We're using the correct DELC now, and it's a static mapping. That's what a manual mapping is called. And broadcast support is enabled. We're using Cisco frame relay encapsulation. The status is defined, and we are active, so everything's good to go. So at this point, I can go ahead and try to ping the remote address, which is 10.1.123.2, and let's see, booyah, success. So now if we go on the other side here, and we issue some of these same commands, let's just go ahead and take a look at the int first. We know that this is correct because we did get end-to-end communications. We see the frame relay. We see that we are rocking the ANSI Annex D. If we do a show frame LMI, same thing, good to go. LMI would not have been affected because, again, LMI is between the router and the frame relay switch. And you can see that we are rocking the ANSI here. So now if I go ahead and do a show frame PVC, I should see PVC 201 here. And that's what I do see. There's a couple of options with this. You can go ahead, in this case it's not a big deal because there's only one PVC being advertised. If you had multiple PVCs being advertised, these two options help out quite a bit. So if you had, like, 201, 202, 203, 204, if you just want to see a specific PVC, because this does give you quite a bit of information, you could specify the DELC, and then you would just get information for that DELC. The other thing I like to do is I like to do an include DLCI. You have to have this capitalized. What that's saying is just give me basically this line. So if there were multiple DELCs here, it's only going to show us this one line. But you can see if you had 5, 6, 20, you get a lot of information from this. You get the DELC number, you get to see if it's active and what interface it is assigned to. From here, we should be able to ping 10.1.123.1, and we can. Now, because we enabled broadcast support, we should be able to ping the broadcast address on this. This is a /24, so it's going to be 255. I'm only going to repeat this one time. And can you guess where the response is going to come from? See, it's going to come back from the .1 address because this is saying, I'm sending out a ping to all members of this subnet. Go ahead and respond if you're on this subnet, and there's only one connection because this is a point-to-point. We'll get into some interesting bits with this when we look at hub and spoke, but with a point-to-point, you should expect a response from the other side of the link. And really, that's it. Let's go ahead and take a look at the running configuration one last time here. The only downfall here was me boning up the GNS setup. I did that on purpose so that we could have some troubleshooting. I don't believe that you're stupid enough to believe that, but I'll go ahead and throw it out there anyways. So again, let's go through this one last time. You want to go in and set the encapsulation of frame relay. In our case, we want to disable frame relay inverse ARP. You need to give this guy a layer 3 address. We're using IP. And then you need to use a frame relay map. And you're going to map the remote IP address to the local DELC. Make sure you know what that DELC is so you don't screw it up like I did. And then if you want, you can enable pseudo broadcast on here, and that's what enabled us to ping the broadcast address and get a response from the actual address on the other side. So let's go back to the slides and wrap this sucker up. While you may not associate point-to-point connections with frame relay, you can certainly configure them over frame relay connections as we just seen. The benefit is that you are paying for a virtual circuit rather than a most likely more expensive dedicated point-to-point leased line. So the configuration is simple, and one of the good things about this lesson is that the configuration, a lot of this is going to stay the same regardless of the type of configuration you're setting up. We're using physical interfaces. We will do lessons on sub interfaces, and we'll find out later that actually you're going to want to use point-to-point sub interfaces for a lot of your configurations, but that's in the future. Let's get back to this. The basic steps are to go under your interface and set the interface encapsulation to frame relay. And there's some optional steps. If you need to, you can set the LMI type. Generally don't have to because Cisco AutoSense is going to take care of that, as we saw. You probably will want to disable frame relay inverse ARP. We'll have more explanation of that in a future lesson. And of course, you're going to need to configure a layer 3 address for the interface so that it communicates via IP in our case, and then manually configure a frame relay IP to DELC mapping, making sure that you know what the correct local DELC is. One more time, it's the remote IP address to the local DELC, and don't bone it up like I did and screw up the local Delcy. Anyways, that's going to wrap this up from here. I hope you got a little bit of a CLI fix here and picked up at least a little bit here when we're taking a look at some of these simple configurations. Next up, we're going to take a look at another simple configuration, but we're going to use a hub and spoke rather than a point-to-point. Please join me in the Packet Lab for that lesson. But that's going to wrap this one up. Thanks once again for joining me in the Packet Lab. As always, I hope this helps you on your route to becoming a network god.